Download this code from codegive.com, link in the description below. OK, let's dive deep into REST APIs, JSON versus XML, and how to work with them using code examples. This will be a comprehensive guide covering the key concepts and practical implementations. REST APIs, a foundation. What is an API? API stands for Application Programming Interface. It's essentially a set of rules and specifications that allows different software systems to communicate and exchange data with each other. Think of it as a menu in a restaurant. The menu lists the dishes, functions, the restaurant, application, can provide, and you, another application, can order, request, those dishes by following the menu's specifications. What is REST? REST, representational state transfer, is an architectural style for building networked applications. It's a set of guidelines and principles that promote simplicity, scalability, and interoperability. While not required, most modern web APIs follow REST principles to some degree. Key principles of REST. 1. Client-server ***, a clear separation of concerns. The client is responsible for the user interface and user experience, while the server is responsible for data storage and processing. This allows each component to evolve independently. 2. Stateless ***, each request from a client to the server must contain all the information necessary to understand and process the request. The server should not store any client context, session state, between requests. This improves scalability because the server doesn't have to track individual client connections. 3. Cacheable ***, responses from the server should be explicitly labeled as cacheable or non-cacheable. Clients and intermediaries, like proxy servers, can then cache responses to improve performance and reduce server load. 4. Layered system ***, the client shouldn't necessarily know if it's communicating directly with the end server or an intermediary server along the way. This allows for things like load balancing, security, and other infrastructure improvements without affecting the client. 5. Uniform interface ***, this is the most important and often debated principle. It defines how the client interacts with the server. The REST uniform interface is built upon these sub-constraints. Resource identification ***, resources, data entities, are identified by URIs, Uniform Resource Identifiers. For example, /users/123 might identify the user with ID 123. Resource manipulation through representations *** clients interact with resources by exchanging representations of those resources. Common representations are JSON and XML, more on that later. Self-descriptive messages ** each message, request or response, should contain enough information for the recipient to understand it. This is often achieved through media types, example content type, application/JSON. Hypermedia as the engine of application state, HATIOS. This is the most advanced, and often overlooked, aspect of REST. The idea is that the API should provide links in its responses that guide the client through the available actions and resources. This makes the API more discoverable and allows it to evolve without breaking existing clients. While not always implemented strictly, many APIs provide some form of linking/pagination. 6. Code on demand, optional. The server can optionally extend client functionality by transferring executable code, example JavaScript. RESTful API design principles. Use HTTP methods appropriately. Get retrieve a resource. Post create a new resource. Put update an existing resource completely. Replaces the entire resource. Patch update an existing resource partially. only modifies specified fields. Delete a resource. Use HTTP status codes correctly. 200 OK, successful request. 201 created, resource successfully created, often returned after a post request. 204 no content, request processed successfully, but no content to return. 400 bad request, client error, example invalid data. 401 unauthorized, authentication required. 403 forbidden, client authenticated, but doesn't have permission. 404 not found, resource not found. 500 internal server error, server-side error. Use nouns, not verbs, in URIs. Resources should be identified by nouns, not actions. For example, use /users and /products instead of /getUsers or /update product. Versioning. Use API versioning to allow for backward compatible changes. This can be done in the URI, example /v1/users, through request headers, example accept, application /vnd.example.v2 plus json, or using query parameters, less common. 2. JSON versus XML, data representation. Both JSON and XML are popular formats for representing data in REST APIs, but they have different characteristics and trade-offs. JSON, JavaScript Object Notation. Lightweight. JSON is significantly more compact than XML. Human readable. JSON is relatively easy to read and understand. Easy to parse. JSON is easily parsed by JavaScript and many other programming languages. Data types. JSON supports basic data types like strings, numbers, booleans, arrays, and objects. MIME type. Application /JSON. XML, extensible markup language. Verbose. XML is more verbose than JSON due to its use of tags. Complex. XML can be more complex to parse and work with, especially for deeply nested structures. Schema validation. XML supports schema validation, using XSD, which allows you to define the structure and data types of your XML documents. This can be helpful for ensuring data integrity. Attributes. XML allows you to define attributes for elements, which can provide additional metadata. MIME types. Application /XML, text /XML. Key differences summarized. Feature JSON XML. Size smaller larger. Readability more readable less readable. Parsing easier to parse more complex to parse. Schema validation limited. JSON schema exists, but less widely used than XSD, strong support, XSD. Attributes not directly supported, can be emulated, supported. Complexity simpler more complex. Widespread use more common for modern web APIs still used in some enterprise systems. When to choose which? JSON Modern web APIs where simplicity and performance are important. JavaScript-based applications. When you need a lightweight data format. XML Enterprise systems that require strict data validation. Applications that need to store metadata using attributes. Systems where existing XML infrastructure is already in place. Data exchange scenarios where a rigid schema is mandatory. 3. Code examples, working with JSON and XML in REST APIs. We'll demonstrate how to interact with REST APIs using Python, along with examples of how to parse and generate JSON and XML. Assumptions Python 3 is installed. The requests library is installed, pip install requests. The LXML library is installed, for XML parsing, more robust than the standard library, pip install LXML. Example API, a fake JSON placeholder API. We'll use the JSON placeholder.typicode.com API, which provides fake data for testing and demonstration purposes. Example 1, get request with JSON response. Explanation 1 import requests imports the necessary library. 2 requests.get, URL, sends an HTTP GET request to the specified URL. 3 response.raise_for_status, checks if the HTTP status code is an error, 4xx or 5xx. If it is, it raises an exception, which is good practice for error handling. 4 response.json, parses the JSON response body into a Python dictionary or list of dictionaries. This is the key to working with JSON data. 5 error handling the try, except block handles potential requests exceptions, example network errors, invalid URLs. Example 2, post request with JSON data. Explanation 1 headers equals content type, application/JSON this is crucial. You must set the content type header to application/JSON to tell the server that you're sending JSON data. 2 data equals. Creates a Python dictionary containing the data to send. 3 requests.post, URL, headers equals headers, JSON equals data, sends an HTTP post request. The JSON equals data argument automatically serializes the data dictionary to a JSON string and sets the content type header to application/JSON. This is a convenient shortcut. You could also use data equals JSON.dumps, data, if you prefer to explicitly serialize the JSON. Example 3, working with XML, get and parsing. Let's create a simple example XML response for demonstration purposes, since the example API does not directly provide XML, and then parse it. Explanation 1 from LXML import a tree imports the LXML library for XML processing. LXML is generally preferred over the standard XML.atree.element tree because it's faster and more feature-rich. 2 a tree.from string, XML_string, parses the XML string into an element object, which represents the root of the XML tree. 3 root.findall, user, finds all the user elements under the root element. The findall method supports path-like expressions for navigating the XML tree. For example, //user would find all user elements anywhere in the document, not just directly under the root. 4 element.find, name, .text finds the name element within the current user element and extracts its text content. The .text attribute gives you the value inside the XML tag. 5 error handling the try, except block handles potential tree.xml syntax error exceptions if the XML is malformed. Example 4, creating XML, post example. Explanation 1 a tree.element, post, creates the root element of the XML document. 2 a tree.subelement, root, title, asterisk creates a child element title under the root element. 3 title underscore element dot text equals title asterisk sets the text content of the title element. 4 a tree dot to string, root, pretty underscore print equals true, encoding equals UTF-8, asterisk converts the XML tree to a string. Asterisk pretty underscore print equals true adds indentation for readability. Asterisk encoding equals UTF-8 specifies the character encoding. This is very important. 5 XML underscore data dot encode, UTF-8, asterisk when sending the XML data in the requests.post call, you must encode the XML string to bytes using UTF-8, or another appropriate encoding, because requests expects bytes for the data argument. 6 headers equals content type, application/XML asterisk as with json, it is critical to specify the content type header to tell the server that you are sending XML. Important considerations asterisk. Asterisk error handling asterisk always include proper error handling using try, except blocks to catch potential exceptions from the requests library, XML parsing errors, and other potential issues. Asterisk character encoding asterisk always be mindful of character encoding, especially when working with XML. UTF-8 is generally the preferred encoding for web applications. Asterisk security asterisk be aware of security vulnerabilities when working with XML, such as XML injection attacks. Use secure parsing libraries, like LXML, and be careful about the data you trust from external sources. 4. Advanced topics. Asterisk authentication asterisk most REST APIs require authentication. Common methods include asterisk basic authentication asterisk sending the username and password in the authorization header. Generally not recommended for security reasons, especially over unencrypted connections. Asterisk API keys asterisk sending an API key in a request header or query parameter. Asterisk OAuth 2.0 asterisk a more complex but secure authorization framework. Asterisk pagination asterisk APIs that return large collections of data often use pagination to break the data into smaller chunks. The API will typically provide links in the response to access the next or previous page of results. Asterisk rate limiting asterisk APIs often implement rate limiting to prevent abuse. They may limit the number of requests you can make per time period. The API will usually return headers indicating the remaining rate limit and the time until the limit resets. Asterisk Hatios, hypermedia as the engine of application state as mentioned earlier. Hatios is an advanced concept in REST that promotes discoverability by including links to related resources in the API responses. While not always strictly followed, APIs may include links for navigation and actions. Asterisk API documentation asterisk good API documentation is essential. Look for comprehensive documentation that explains the available resources, HTTP methods, request parameters, response formats, authentication methods, and error codes. Tools like Swagger/OpenAPI are often used to generate interactive API documentation. Asterisk testing asterisk write unit tests and integration tests to ensure your code interacts correctly with the API. Asterisk tools asterisk consider using tools like Postman, Insomnia, or Swagger UI to test and explore REST APIs. In conclusion, REST APIs are a fundamental part of modern web development. Understanding the principles of REST, the differences between JSON and XML, and how to interact with APIs using code is crucial for building robust and scalable applications. The examples provided here should give you a solid foundation for working with REST APIs in Python. Remember to always consult the API documentation for the specific API you're using, as each API may have its own unique requirements and conventions. Good luck.